Today, we're going to take a look at an optimization for parallax mapping in Unreal and Unity. Let's go! So in a previous video, I talked about parallax mapping and what it is and why we use it, but I want to go over it just briefly again, just so that we'll all have the proper context. What we're looking at here is a completely flat plane, but because I'm using parallax occlusion mapping, it looks like these cobblestones actually have surface shape and depth. So when I look at them at a steep angle like this, you can actually see the shape of the cobblestones, even though this is applied to a completely flat plane. And if I come over here and switch to wireframe, you can see that this plane is just completely flat. There's no geometry here for those cobblestones at all. When I set my scene back to shaded mode, you can see that now it looks like there's this amazing amount of shape on the surface of my model because I'm using parallax occlusion mapping. When we compare that scene with the same plane that's just using regular old normal mapping, you know, there is a little bit of shape to those cobblestones, but there's just like a significant amount of flatness going on. And the parallax occlusion mapping adds so much detail. Here, I'll turn it back on. So when we have an effect like this, a material on a flat surface, or it even doesn't have to be flat, you can map this to nicely shaped terrain as well. When we have a material applied like this, using parallax occlusion mapping can add a lot of realism. However, if you're not careful with how you apply it, it can also be very expensive. And today what I want to show you is both how to set up this effect and also how to make it cheaper so that it's not too much more expensive than just regular old normal mapping. And what we're going to do is put the expense of the effect where it's visible and get rid of the expense of the effect where it's not visible. So let's go ahead and jump into the shader. Here you can see that I've got my shader set up and I'm using my cobblestones texture set here. Let's just switch these previews over to using 2D. And we'll take a look at the same thing in Unreal in a minute, but we're going to start out looking at it in Unity. So you can see that I've got my textures, my albedo texture, my normal map here, and my mask texture. And then over here, I'm creating the UV coordinates or the texture coordinates using the parallax occlusion mapping node. I can just type parallax and there it is, the parallax occlusion mapping node. So in order to make this effect work correctly, the main thing that I need is a texture that contains the height. So here I have cobblestones underscore H, and you can see that this is a height map texture, and this one is only 256 by 256. If we compare it with the normal map, for example, here's my normal map. You can see that my normal map is a 2K texture, and it's quite a bit sharper. But my height map here, I've reduced the resolution, and I've actually blurred it a little bit because parallax occlusion mapping works better when you don't have sharp edges. And this particular material, the height map did have sharp edges where the sides of the cobblestones are really steep. So I blurred it out a little bit just to add some gradient along the edge so the effect will work a little bit better. So I placed my height map here in the height map slot. We have this input here called steps, and this steps value is the main focus of today's video. This is the single most impactful feature or value that controls the performance of this effect. And basically what it is it's the number of samples that we're using to create the effect. So right now I've got it on 128, and that is really excessive, but it also gives me really high quality. You can see if I come down here, zoom in really close and get a nice steep angle, these sides of my cobblestones are really nice and smooth, and that's because I'm using 128 steps to create this effect. Now, if I reduce that number, let's just set this to something like 5, for example. And now you can see that the quality has been reduced significantly. It starts to look like my cobblestones are made out of a stack of pancakes. And if we count here, 1, 2, 3, 4, 5, we can actually see the steps on the sides of the pancakes. So because I've reduced the steps down to 5, this effect is significantly cheaper to render, but it also looks really bad. Like, it's just completely pulling itself apart over here, kind of in this mid-range distance. And in the foreground, you can actually see this little section right here. There's this top piece and then a gap and then the next piece. So it's just really not working with this number of steps. So what we want to be able to do is put the steps where we need them and remove the steps where we don't. And so what we're going to do is create a mask that controls the number of steps that we're doing based on a couple of factors. First of all, when I'm looking straight down at my cobblestones, I need almost no steps at all. You can see there's none of that kind of artifacting happening where the effect is pulling itself apart here. The artifacting happens when I'm looking kind of parallel along the surface. So the first kind of optimization we're going to create is a reduction in steps depending on the angle of the camera to the surface. So I'm looking straight down, we want to get rid of steps. And when I'm looking out toward the horizon, we want to add steps. So let's go ahead and do that. All right, so back in my shader graph, I've created a mask that looks at the relationship between the surface of the object and the camera direction. So here's the camera direction, or the view direction, and here's the surface of the object, or the normal vector. And I do a dot product between these two and then saturate that. So let's go ahead and take the results of these nodes here, and I'm just going to plug them into base color. For now, I'm going to disconnect these other values just so that we can just see our base color to see what our mask is doing. So we're doing a dot product between the normal of the surface and the view direction, and then saturating that. So let's switch over to our scene. So what we can see here is when I'm looking straight down, the surface is white, but then as I look out toward the distance, it starts turning black out here. And if we look at it in the main preview of Shader Graph, you can see something similar. So my surface is kind of white looking straight at the object, and then around the edges, it turns black. Now I'm inverting that effect with a 1 minus and then multiplying it by itself, or just basically raising it to a power of 2. So let's plug this into our base color and see what we get now. All right, so now we're getting black when we're looking straight at the surface, and then white along the edges. And if we switch over to our scene, now you can see if I'm looking, actually, let me open up the analysis render debugger, and I'm going to switch our material just to show us just the albedo, or the base color. So you can see when I'm looking straight down, I get black, but then as I'm facing like more parallel to the surface, I get white. And we can use this mask to turn down the number of steps when we're looking straight down, and then turn it up again when we're looking out toward the horizon or parallel with the surface. So let's go ahead and do that. We're going to take this mask that we created. I'll just disconnect it from our master stack there. I'm going to move it around here so that it's near our steps. And we're going to take the result of this and we're going to multiply it by, so we had a number of steps of, so we got 5 there, but really what we want is 128. So I'll set 128 here, or actually we can probably get away with less. So let's do 32 for now. And then after we multiply it by the maximum number of steps we want, we're going to add a ceiling node so that we're rounding up to the nearest whole number. This is so that we never get fewer than 1 steps. So we'll go ahead and wire that into our steps count there. And so what this is doing is when I'm looking at the surface kind of parallel with the surface, I get the maximum number of steps. But then as I look kind of straight down at the surface, my step count is reduced until if I'm looking straight down, I get 0. And then because I have the ceiling node here, it's going to round it up to 1. So I'm going to get 1 steps when I'm looking straight down at the surface, and then 32 when I'm looking kind of parallel with the surface. And let's hook up our textures again. Great, and we'll switch back to our scene. Yeah, so now when we're looking straight down at our model, our steps are 1, but then as we look out more toward the horizon, we get an increased number of steps. And that problem that we were having before, where we're getting that pancaking, is gone because we're able to raise our maximum number of steps up to 32. If we get down to this like really parallel angle, you can still see just barely this little artifact here. But we've created this optimization. So now when we're looking straight down at our surface, we're not doing all 32 of those steps. We reduce our step count to 1 here, but then as we look out this way, it increases our number of steps so that we get that detail where we need it. So that's going to increase our performance by quite a bit, actually. Now, the other optimization that we can do is, this is an effect that's really nice when you're up here close to the surface. But if I zoom out and start looking at my surface from this kind of a distance, it doesn't make sense to be calculating all of those steps because I really can't see any of that nice parallax on the surface anyway. So, in addition to the angle mask that we're already using, we can create another mask that reduces the number of steps as we get further away from our model. So let's go ahead and do that. I'll switch back to the shader. And here I've gone ahead and created that distance mask. So what I have right here is the vector that goes from the camera to the point on the surface that's currently being rendered. So this is an imaginary line that goes from the eye, or where I'm seeing the scene, to the point that's getting rendered. And I measure the length of that line to find out how far away it is. Then to adjust my mask, I'm multiplying by 0.09. I saturate the result, and then I raise to a power of 0.04. And this is just to kind of adjust the fall off of that curve. And then I add a 1- node to invert it so that it's white near the camera, and it falls off to black further away from the camera. So let's just go ahead and plug this mask in. We'll plug it into our base color, and we want to take a look at the results that we get from that distance mask. So I'm going to plug this into my base color here, and let's save that and switch back to our scene. So now you can see when I'm close to the surface, I get a value of white. And then as I pull away from the surface, you can see I have this nice gradient here where this area is black. So I'm going to get the least number of steps here. But then as I get closer to the surface, it's going to increase the number of steps where my mask is white. So I've got two masks. I have this one, which is the distance from the surface. And then I have this other one here, which is the angle of the surface. So I can take both of these and multiply them together, and then plug them into my multiply here, and I'm multiplying by my maximum number of steps there. And then I plug into my ceiling like I was doing before. And then I plug that into my steps. So what I'm doing is I'm putting steps only when I'm sort of parallel to the surface and close to the surface. But if I'm perpendicular to the surface, I'm looking straight down at it, or I'm further away, I'm getting rid of steps as an optimization. So let's go ahead and plug in our textures again. Perfect. And now let's look at our scene. So here, when I'm close up and looking parallel to the scene, I'm getting my maximum number of steps kind of right around in this area. And then as I look down, my step count is reduced here. And it's also reduced as I zoom out and pull away from my scene. Now, if you take this scene and measure the performance cost of this, maybe, scene kind of like this, and measure the performance cost between what we've just done and just a static step count. So if I were to disconnect this wire here and just type that value directly in, if I were to give this a value of 32, so it's just a static step count of 32, I think you would be pleasantly surprised between the savings that you're getting from reducing the number of steps in our parallax occlusion mapping node where they're not needed, when we're looking straight down and when we're kind of looking out or when we're further away from the model. All right, so there is your optimization for the parallax occlusion, and this will allow you to use parallax occlusion in a lot more cases. If you weren't using it before because it was super expensive, go ahead and try this technique where you're masking it out based on the distance from the surface as well as the angle to the surface. And I think you'll be really happy with the results or the savings that you get from this optimization. All right, let's go ahead and switch over to Unreal, and I'll show you how to do the same thing there. All right, here we are in Unreal, and you can see I have a very similar scene here. I'm still using my cobblestones setup, and I've got the parallax occlusion mapping effect applied. And you can see that I'm getting the similar kind of a thing. If I get down here really low and kind of go parallel, here you can kind of start to see that pancaking effect. I've got this set to a maximum number of steps of 32 right now, but at this kind of an angle, it does start to fall apart. So hopefully you can prevent your camera from getting at this kind of angle, or you can afford to increase the number of steps so that this improves. Let's go ahead and take a look at our shader. So here are our textures. We have our color texture, our mask texture, and our normal map. And then we have our parallax occlusion mapping node here. Wow, Unreal has a whole bunch more settings here. So here are our steps. In Unity, we just had one single step input, but Unreal has minimum steps and maximum steps. Let's go ahead and take a look inside our parallax occlusion mapping node, see if we can figure out what that minimum and maximum step thing is doing. And this actually looks kind of familiar. We were just looking at this in Unity. We're doing a dot product between our camera vector or view vector and our normal. And then we're using that to blend between the minimum and maximum steps. So Unreal's parallax occlusion mapping node is already doing one of those two optimization techniques. So when we're looking straight down at our surface, like straight at this preview sphere here, we're going to get the minimum number of steps, which is 2. And then as we increase the angle, like coming over here to the edge, it's going to start increasing the number of steps up to 32. So Unreal is already doing half of the optimization that I showed you just now in Unity. However, as we move further and further away from this thing, we're still going to be using the number of steps. There's no optimization here for distance. And so we're going to go ahead and add that in. What we're going to do is take this max steps value. Right now it's just hard-coded to 32. And right here, I have the same thing that we created in Unity, where we're measuring the distance from the camera and then adjusting that mask just a little bit to create or to reduce the number of steps as we get further away. So we find the distance between the position that's currently being rendered and the camera. Then we multiply that by 0.0009, And this number is a lot smaller because in Unreal, we're dealing with centimeters instead of meters. Then we saturate that value and then raise it to a power of 0.05. Then we invert it with the 1- node. And then the rest of this here is just so that we can connect it with our maximum number of steps that we have down here. So I'm going to bring this mask in. Then I'm going to connect in our 32 value here, which is our max number of steps. Then we're raising it to the nearest whole number using the ceiling node. So I'm just going to plug this into the maximum number of steps. So there's our mask, our distance mask. Actually, you know what? Before I do this, let's take a look at this mask by itself and just see what it's doing. So I'm going to grab these nodes here and move them over. And what I want to do is just plug that into base color. And we'll switch back to our scene. What I wanted to show you here is that when we're far away, we get a value of black. And then as we get closer, it turns to white. So from this kind of a distance, we don't want to be using any steps or the least number of steps. And then as we get in close, we're going to switch to our full step count where we actually need it. Okay, so I'll go ahead and plug our base color back in. We'll move this mask back over here where it belongs, and we'll hit save. And now, as I zoom in, I'm getting more and more steps, and as I zoom out, I'm reducing that step count to the minimum number. Now, as I said before, when we were taking a look at this in Unity, I think you'll be pleasantly surprised, especially if you're using this on landscape. You want to have steps up here close when your player is looking like directly at the ground around him. But as you're looking further off into the distance, boy, what a waste to be doing tons of steps way out here where you can't even see them. So we want to make sure that we reduce that step count as we move away. And so we're doing that here. And again, if you measure the difference between doing this with and without that, I think you'll be pleasantly surprised at the results that you get. All right, so that is an optimization for parallax occlusion mapping where we're increasing that step count and only getting steps where we need them when we're kind of parallel with the surface and close up, but not putting steps where we don't. And we're able to save a bunch of performance by doing that. I hope you enjoyed the video today. Let me know if you have any questions about this stuff, and be sure to come back next week. I think we're going to do a glass material for next week's video. All right, have a great week, everybody, and we'll see you next time.